Now, in any type of data science project that you're doing, the 80% time you're always working with the data. This data can be a data pre-processing stage, is majorly the data pre-processing stage, or the which includes the cleaning, imputing, scaling issues, and removing outliers in the data set, etc., etc. So this whole EDA part is very, very important in the whole data science lifecycle of a project. Now, after this, when we are just before the modeling stage, the machine learning model building stage, just between these two stages, there is a stage where we do this, split the data set into training and the testing data. And this training data is again split into two different parts. One is actual training data and one is the validation data set, right? Now, if any type of information, no, the test data is treated as what? The hidden or the unseen data set. So we know that how will the model perform after after being trained and after recognizing the patterns in this whole training data set. It is able to, how is it able to perform? Is it able to perform well in the real world scenario on the hidden unseen data set or not? This is a crucial check. Now, this might give a false perspective of a very good accuracy if any type of information from the test data leaks inside the training data, because we are doing a form of cheating here. The test data set is supposed to be hidden, but we are capturing some information, crucial information, and passing it to the training data set. And this is like a type of cheating only in the language of data science. So this issue is known as data leakage. If I need to specify it formally, I will say that when any type of information, any type of data, or any type of like intricacies of from the from test data leaks into the training data set. What type of information from test data can leak into the training data set? For example, if this training data has this type of distribution, a normal distribution almost, right? And the test data, the hidden data, which actually occurs in the real world scenario, was completely different. And we wanted the model to know whether it performs good on this left skew distribution or not, which is quite different from this one, the training data. But if we leak this information, or some pattern of this information to training, the training data set will look something like this. So this is a form of cheating. We cannot leak this information here because we only need to use the knowledge of the historical data to predict the future outcomes, right? So this is called as data leakage. Now, this can be defined other terms also. Some people define it when the information from target label Y leaks into the feature columns X. Let's move to a different page. So we are done with two type of definition for this. When test information, test data information leaks into training data, which is majorly used as this definition for data leakage. And another type of definition is that when target label information leaks into the feature columns. Like for example, when we I should first do it one example. So let's move to the first definition. Test data leaking to the training data set. Imagine you have a data set with only one feature column, right? Which let's treat it as a feature column x1. And this is the whole training data set, and this is the whole test data set, right? Now, when you are in the data pre-processing stage, that's when the issue of data leakage arises, right? In data pre-processing stage, if you are doing scaling of this column, it can be any type of min-max scaling, getting the feature values from 0 to 1, or any type of standard scaling. making the mean 0 and standard deviation 1 or variance 1, right? I will explain in later videos what is the scaling and how are they different. So if you are doing scaling, okay, and you are scaling the training data set, right? For example, this is a distribution of the values 1, 2, 100, 99, 50, very different distribution. And you can need to calculate if you are doing this standard scaling. You need the mean of the feature columns, right? So while calculating the mean for the training data, if you calculate the mean including this test data also, then you have a kind of data leakage because in this mean you calculated, for example, in test data you used a value like 300. So when you calculate the mean using 2 plus 100 plus 80, it was right. But the moment you included 300, this came from the test data. So this 300 is quite an outlier for this column, right? So we wanted to test whether how is it how well the model will perform on this unseen peculiar type of data point. But you leaked some information here. So the model is now accustomed to this type of outliers. So it will perform well on the during the training phase because you leaked some information. But in the real world scenario, where this type of peculiar values will come continuously, the model will completely fail. This because you included in the mean during the data pre-processing stage, this test data also. This is how the data leakage issue occurs. Now, in this case, how will you remove this data leakage issue? There's no space, I'll move to a different page. Instead of, and this is the problem that many of the young data scientists have seen doing. And including myself, they, what do they, is they scale first. Sorry, many young data, so what do? They scale first and then they do the splitting, which is quite wrong. Because if you scale, you are without splitting, you are including the test information also in the training data set, right? But so to remove data leakage, you need to split and then scale. That is scale dot fit transform the training data set so that you get the mean and standard deviation from the training data set. And then on the test data, you only do the transformation because this mean and standard deviation from the training data set will use to transform the test data. Mean and standard deviation calculated from training will be used to scale this test data. So no information from test is used in this mean, only information in this mean is stored from the training data set. I know it sounds a bit difficult for now, but if you practice, you'll come to know. Use it in your projects, much better to understand now. And the second scenario is not too difficult to understand. It just means that when you are using any type of information from the target variable. Imagine if we have a data set like this with feature column x1, x2, and a target label y, which we have to predict. So if you are using this target label y or any type of target label which is in direct correlation with y, then or any type of y1 which is dependent on y. So and if you are using any feature columns are actually what called independent variables they are called. But if you are using any dependent variable which is directly dependent on the target variable, then it will cause a data linkage issue. Because imagine you trained on this data set, the model performs very good because these two values are quite dependent. So the model knows if it got a y1, it will get a y. Training accuracy is 100%, 90%, 99%, very good, but it will cause overfitting. Why? Because when a new data point comes in real world scenario, you will have only the feature columns. Why will you have y1? Because y1 is dependent on y, and in the real world scenario, we have no target labels. This is what we have to predict. So if you do not have this, you will not have never have y1 because these two are dependent. A good example I can say is that if you have to predict the number of tablets for incoming patients in a hospital, and one of the feature columns is of diagnosis, it's a data leakage issue because how will you determine the number of tablets? That is, number of tablets are dependent on what? The type of diagnosis the doctor gave, whether the cholesterol level is greater than 100 or less than 200 or greater than 300. Then tablets give 30 tablets, 10 tablets, etc. So when a new data point will come, you will not have the number of tablets, and therefore you do not have the diagnosis. I mean to say, this is completely dependent. So unless and until you have number of tablets, you cannot, unless you have the diagnosis, you cannot determine the number of tablets, and vice versa, right? So this is how the whole data leakage issue works, and hope you understood.